Oh hey, that's my start timer all ready to go. So let's see, where are we? Let's try this view. Hello Twitch. Maybe I want the extra webcam down here. And over this. Is this worth it? Yeah, probably. Pardon me while I sort out the hitches with this. Let's bring in this camera. Okay, and bring out the music. Takes it a while to fade out gently, which is nice, I guess. Let's turn on a light. It's almost too bright. Okay, let's get into it. Have a drink of water. Okay, here is the plan of action. I am going to, you know what? I want my full screen. So I'm gonna do this and expand this thing in that way. We are working on musical Markov Chains. This code here is just some boilerplate in order to... It's interesting that the camera is over there. In order to let the keyboard over here play a note in Sonic Pi. And what I'm going to use that for is I'm going to play some, basically just some like exercise, some basic exercises. Scale up and down, arpeggio, and then thirds. Okay, what am I going to do with that? I now have an output that I think I hope I can select it. Maybe I can't. I could have sworn we could do that. What if I puts note? Run that code. Well, this is great. I remember being able to copy paste this. Hello, 1, 2, 3, 4, 5. Is that the syntax there? Not quite. Okay, we'll just do this the old-fashioned way. That's slightly annoying. So I just have to, I guess, type this all out. Um, sixty, 2, 4, 5, 6. I'm sure this is thrilling. Starts with 60. Do, re, mi, fa. 65, 67. 69, 71. 69, 71, 72. And now this is going to continue. $72, $71, $69, $67, $65, $64, $62, $60. Then $60, $64, $67, $72. $72, back down. 67, 67, 64, 60. Six, 0. And the thirds, I could figure out the pattern to this and write code to generate these numbers, but I'm just going to do it this way. 60, 64, 62, 65, 64. Four, 67, 65, 69, 71. Oops. 69, comma, 72, 71, 74. 69, wait, 64, 67, 65, 69, 67, 65. Oh my. How many can I see at once? 1, 2, 3, 4. 60, 64, 62, 65. 64, 67, 65, 69, 67, 71, 69, 72. That's what I needed here. I swear I could copy that before. That's so weird. $57, 71, 69, 72. 71, 74, 70, 72. Then this thing kind of backwards. 72, 71, 74. 72, 74, 72, 71, no, 72, 69, 71, 67, 69, comma, 65, comma, 67, comma, 64, comma, 65, 62, 64, 60, 62, 59, 60. Woo! That was more difficult than I expected. For T in N in T, is that something I can do in Ruby? It's Ruby. No, that's not right. Shoot. Ruby for loop over array. Thank you, Google. T dot each item puts item there we go. Still can't select the text, but synth piano note amp. I don't care about velocity. Okay. Not at all very exciting, but we're building up to something here. Now that I have these notes, I'm going to move over to Python, which is a language I'm more comfortable in. Maybe I could do this in Ruby. But I think I'm going to do this all in Python. Oh, Godot is still open. That's interesting. Also, musical Markov Chains notes is there. Be right back while I open up PyCharm. New project. Okay. We are back with PyCharm. Oh, I called it Python Project 3. That's silly. Oh well. Python file main.py. So I'm working with my list here. And I'm just to make this clean, I'll add another repeated 60 at the end there. For I in range, this is a little unPythonic of t, but I'm going to do it anyway. If not t at t of I, t at t at I, and b is a dictionary, equals a list with t at I no it's the it's a list, and in that list is t of I plus 1. Else dict at t of I dot append t at I plus 1. Now print the. Let's run that. That didn't take long. If ti not in the dot keys, sure. Length of t minus 1. Length of t minus 1. There we go. So what do we have here? Let's debug this so we can take a look at the dictionary once it's gone through all of that. Oops. Bumped the camera. Good thing that wasn't good thing that camera didn't have the microphone. Is the camera still there? It's not very much visible. So here's the dictionary. You see it has keys of 60, 62, 64, 65, 67, and so on. And each of those has a list of the numbers that 67 has gone to in that one. So output is an empty list. I realize I'm not really explaining what I'm doing here, which is probably being a bad streamer. But I may like go through this process a couple of times and have the explanation improve as I do that. Output, that should be output. Let's do this 100 times. Start equals random dot choice, and let's import random. Random dot choice. Is this not a thing? Oh, just import random. Random dot choice d dot keys. Why is it complaining? Maybe I have to cast that to a list. 100 current equals that. Next equals. So we have d at current. And we take a random dot choice against d dot current, and current print f string current. And actually I can just say current. Well, Sammy, okay. Yeah, cat's coming around. Good kitty. Bumping the mic a little bit, which isn't ideal. Just exploring, doing cat stuff. Current equals random dot choice of d current. Okay, let's run this. We should get a big long output. Yes, we do. Except I want to add print sleep 0.5, control run. Cool. Now let's go back to Sonic Pi. And we copy in all that ugly code. Actually, I could just output a list. I didn't have to do it that way. Anyway, let's run this. Oops, what's wrong? Oh, it doesn't recognize Python syntax. That's fair. I think this is low-key fascinating. The one thing I'm going to change is it's a few 60 is repeated a few too many times. So let's comment out a few of the 60s. Run this, except this time, instead of printing out all this nonsense, output.append current, and then can I just print? I don't want a bookmark there. That was an error. Okay, let's try this. There we go. Now, instead of all this junk, of which there's a lot, how far did this go? Only 100, but it went to more than, oh, of course it went to more than 100 lines because it was 2 lines per thing. T2 equals this list. Fortunately, it's the same syntax for a list. Then I can do t2.each, and let's run this one. I feel like it's longer than it needs to be. Okay, break time. Okay. Let's start from the beginning and I'll try to explain what I was doing. So I started by just playing a simple melody on the keyboard. And then the arpeggios. And so on. And if we uncomment these numbers, we can see that it's going to play the same melody back at me because the numbers that I wrote down correspond to that melody. And you get the idea. Then I took these numbers and I went into PyCharm. Wow, PyCharm, don't give me that. I import random because it'll be useful. This is just being fussy, but oh well. I'll also take out or make them more pretty. I don't know if that was worth the time it took. But I have this list of notes, and notice that after note 60 comes 62. But in another case, after note 60 comes note 64. That will become relevant. We have then D is a dictionary, and for I in range of the length of T minus 1, so whatever the length of T is, if it has 20 elements, then we'll go in range of 19, which means we'll actually go from 0 to 18. And that's important, as we'll see. And now we look at d.keys, and if the value at I, let's close this run window. If the value at index I, so starting here, print D. Oh, D is just the dictionary. Yeah. Okay, I got this. D is a dictionary, and we look to see if this number is in the keys of the dictionary. If it's not, then we set the dictionary at that. You know what? This would be a lot easier if current note equals T at I. And you know what? Let's be nice here and say this is list of notes, or let's call it input melody. Okay, PyCharm, you can reformat the file. Current note equals, we need to refactor this. Shift, I think it's F6. No. Oh, Shift F6. Ah, darn it. Okay, find T, replace with, no, input, current note equals input melody. Current note equals input melody at I. If current note is not in d.keys, then d at current note, let's also say next note equals input melody at I plus 1. That's the reason for the length of melody minus 1 here. D of current note equals next note. So we have a list that contains just the next note. Otherwise, we say dictionary at key of current note dot append next note. Okay. having done all of that, I want to check my terminology here. Is it a Markov dictionary? Just Markov chain. I'm wondering whether I should call it, instead of calling it D, maybe there's something more meaningful I can call this variable. Um, I'll call it the Markov dictionary. So then if current note is not in the keys of the Markov dictionary, then Markov dictionary at current note equals a list containing next note. Otherwise, we take Markov dictionary at current note and we append to it a next note. Print the Markov dictionary. Now we start with current equals random from the listing the keys. And then we don't need that anymore. Output.append current note, and then current note, let's call this current note current note call this not copy, control F6 maybe? Oh, I don't remember I don't remember how to refactor in PyCharm. Here we go. Output melody. There we go. That's better. Let's make sure this thing still runs. It does. Let's make sure we get a different output each time. Yes, we do. And there we have it. I'll copy this output result, put it here in T2, and let's listen to it. Okay, I think I'm ready to try to make a video out of this. Also, let me do something here. A Markov chain is a stochastic model describing a sequence of possible events in which the probability of each event depends only on the state attained in the previous event. Informally, this may be thought of what happens next depends only on the state of affairs right now. I'm going to paste that into my Markov dictionary, Python, thanks. Current note equals list of possible notes. Jump from note to next note. Generate a randomized quote unquote melody. Okay. Let's record in 3, 2. Oh, I thought I had an intro hook and then I lost it. Ah, that's funny. Blooper reel for that one. That actually works. More or less. Okay. Let's hide this extra webcam. I think it's just a distraction here. And in 3, 2, 1, I'm going to talk about musical Markov chains. 3, 2. In this video, I'm going to talk about musical Markov chains. What is a Markov chain? A Markov chain is a model for explaining how things happen that says what happens next depends only on the state of affairs right now. I'm going to represent that in code with a Markov dictionary and have it be that from the current note, at the Markov dictionary at the key current note is equal to a list of possible notes. And at each note, I'll jump to the next note from the list of possible notes, and in that way, generate a random melody. Let's see how that works. The first thing I need is an input melody to define kind of, well, to analyze a melody. The point is we need to input something. So let's input the following. I played it on the keyboard, which you can't hear right now for some reason. But let's try to play just this melody. So it starts like that. Wait, is this not recording my thing? Oh, it's recording my thing. I'll probably edit some of that down. Let's listen to well, we'll go into a new buffer for that one. No, we won't. Let's listen to a little bit of the input melody. Okay, I took that melody and I put it into PyCharm so I can work with it in Python. Here we have, oh, I need to change my scene. Here we have it, the list in Python. I commented out some of the 60s so they wouldn't be too repetitive. I say that Markov dictionary is a dictionary. And for oh, oops. Come on, PyCharm, what are you doing? For I in range of length of input melody -1, current note is equal to input melody at position I, but next note is equal to input position at melody I plus 1. And this is the reason that we don't have all the way up to range. Now, if current note is not in the Markov dictionary keys, we say that Markov dictionary at key current note is equal to a list containing the next note. Otherwise, Markov dictionary at the current note, which is already a list, we append the next note to that, and we print the Markov dictionary. Let's run the code and inspect the Markov dictionary. You can see 60 goes to 62, 64, 64, and 62. 62 goes to 64, 60, 65, 64, 59, and so on. I won't read you the whole dictionary, I promise. But what do we do with that next? We take output melody as an empty list. Current note is a random.choice, so we're choosing a random element from the list of keys from the Markov dictionary. And for I in range 100, we take the output melody, we append the current note, and then we say the current note is equal to random.choice of Markov dictionary at the current note. And remember from my notes before, I stated that Markov dictionary at current note equals a list of possible notes. So we're getting the current note comes from the list of possible next notes. And we print that output melody. Here it is. Let's go back to Sonic Pi, comment out the part where we were doing list 1, paste in our new randomized list, uncomment the code that plays it, and now let's listen to something that's going to have a similar structure to the input melody, but sound totally different. Here it goes. And there you have a musical Markov dictionary. Okay, definitely maybe not break time, actually, based on the time that I see here. Thanks for hanging out while I tried to record that video. Oh, let's go to the BRB screen. That's interesting. Oh, I'm still on Twitch. Ha. Maybe I should do something about that. I'm gonna hide this guy and move myself kind of over here. Okay. Let's try again to make a video about Markov chains in 3, 2. Musical Markov chains. First, what is a Markov chain? One definition of a Markov chain is it's a model describing some process where what happens next depends only on the current state of affairs. In analysis of a melody, I'm going to represent that in Python code by saying that Markov dictionary at the key current note is equal to a list of possible notes. And I'll generate a random melody by jumping from note to note. That will make a randomized melody. But where is the input data going to come from? I'm going to use an input melody that I played on my keyboard, and it sounds like this at the beginning. And it goes on a little bit more. It's pretty simple. Okay, that's enough to give an idea of it. I took that melody from Sonic Pi, which is this program. I put it into PyCharm, and I imported random because I'm going to be making random selections. So here's the list. I can scroll down through it. Here's that Markov dictionary I mentioned. It's a dictionary. And I'm now going to populate that dictionary in the following way. Let's close the run window. Actually, let's use it to be just the right size. For I in range of the length of the input melody minus 1. What's the input melody? It's just this list. Current note is equal to the input melody at I. next note is equal to the input melody at I plus 1. And if current note is not in the keys of the Markov dictionary, then the Markov dictionary at current note is equal to a list containing next note. Otherwise, Markov dictionary at current note, which is a list, we take that and we append next note to that list. We can print the Markov dictionary, and I'll run this now. Scroll this up. It's this here. So 60 can go to 62, 64, 64, or 62. Meanwhile, 64 can go to any number of these notes. Once I've made the dictionary, it's time to generate the output melody. That starts as an empty list. I initialize current note as random.choice from a list of the keys of the Markov dictionary. And then for I in range, let's only go to 35 this time. Output melody.append current note, and current note equals a random choice taken from Markov dictionary at current note. Now remember, I defined that Markov dictionary at current note equals the list of possible notes. So we're jumping to the next one of the next possible notes. Finally, we print the output melody. Let's run that. We get an output list, which I'm going to take back to Sonic Pi in another code window that I've prepared. Make this a little bigger. And let's run this. So, in conclusion, there you have musical Markov chains using Python and Sonic Pi and some basic little... Oh, it's not playing. Okay, time to end the video. Thanks for watching. Okay, I think that's good enough to go up on YouTube. What next? What next? Maybe that's it for the stream for tonight. That might be enough. How's everyone doing out there in streaming land tonight? Okay, yeah. I think that's stream enough for tonight. It's getting kind of late. Who could we raid? Is it even worth raiding someone right now? I think it is. I don't see anyone. Oh, YK Dojo is on. I wonder if I want to raid YK with one viewer. Let's listen to another Markov chain while I decide. Let's listen to a longer one. Okay, let's call that a night. Thanks for watching, everyone. Have a good night.